In the previous episode, we explored the differences between CPUs, GPUs, and ASICs. Each one had a completely different role and strength.
CPUs were the elite craftsmen. GPUs were the army of 10,000 workers. ASICs were the overpowered one-move anime characters.
That is still one of the strangest summaries we have ever created, but somehow it works. However, there is another really important layer to this story.
There is more? Semiconductors have too many species. This industry has more evolutions than Pokemon.
Honestly, it is not that far off. Because semiconductors are not just one thing. AI GPUs are semiconductors. Smartphone storage is also semiconductor technology. Even power control systems in cars use semiconductors. They all belong to the same industry, but their roles are completely different.
So semiconductors are basically a giant fantasy guild with different job classes.
That is actually a very good analogy. Today, we are going to focus on three major categories: logic semiconductors, memory semiconductors, and analog semiconductors. And by the end, you will understand how all of them work together to support modern AI systems.
Today's episode is basically the semiconductor class system.
Let us start with logic semiconductors. These are probably the chips people imagine when they hear the word computer chip.
The smart chips.
Exactly. Logic semiconductors are responsible for calculating, processing, and making decisions. In other words, they are the brains of modern electronics.
So CPUs and GPUs belong to this category?
Right. CPUs decide what tasks should happen next. GPUs perform massive calculations in parallel. Both are fundamentally thinking chips.
So, logic semiconductors are the strategy department of the semiconductor world.
That is a good way to describe them. And because AI workloads require enormous amounts of computation, logic semiconductors became the center of the AI boom. NVIDIA GPUs, Google TPUs, and AI accelerators are all logic semiconductors.
So, most semiconductor headlines lately are basically logic semiconductor drama.
Honestly, yes. But there is an important catch here.
I knew it. There is always a hidden boss fight.
Logic semiconductors alone cannot run a computer system.
Wait, what? So, the protagonist party forgot to bring a healer again?
A very dangerous adventure party, yes. Because once logic chips start calculating, they immediately need something else: memory. Now, let us move on to memory semiconductors.
These sound exactly like the storage class characters.
That is basically correct. Memory semiconductors exist to store data. If logic semiconductors are the thinking side, memory semiconductors are the remembering side.
So CPUs are like, I shall calculate, while memory chips are like, here are the documents you asked for.
That is honestly a perfect analogy, because CPUs and GPUs constantly need data in order to work. AI systems especially need enormous amounts of information: training data, model parameters, and intermediate calculations. All of that has to be stored somewhere.
An AI with no memory would just stand there going, please remind me who I am.
That would be a very concerning AI. One major example is DRAM. That is the high-speed temporary memory used in PCs and servers.
The thing people brag about when they say, my PC has 64 gigabytes of RAM.
Exactly. Another important type is NAND flash memory. That is used in SSDs, smartphones, and storage devices. It is where your photos, videos, and files are stored.
So, memory semiconductors are basically the giant warehouse district of computing.
That is a very good way to see it. But in the AI era, one particular type of memory became extremely important: HBM.
Another mysterious three-letter boss character has appeared.
Now let us talk about the third category: analog semiconductors.
This suddenly sounds like a physics class.
The name definitely sounds technical, but the core role is actually pretty simple. Analog semiconductors exist to control electricity.
Electricity itself?
Exactly. Managing voltage, stabilizing power, controlling current, and handling energy conversion are all analog semiconductor tasks.
That sounds incredibly unglamorous.
It does sound that way. But here is the important part. Without analog semiconductors, everything stops.
Wait, what? So they are basically the support class carrying the entire raid team.
That is actually very accurate. Modern AI GPUs consume enormous amounts of power. Some AI accelerators now use electricity at the level of household appliances.
GPUs are slowly evolving into microwaves.
Honestly, the power consumption is getting pretty intense. And because of that, systems need stable power delivery, heat management, and voltage regulation. All of those depend heavily on analog semiconductors.
So, analog chips are basically the electrical infrastructure of the AI era.
Exactly. And analog semiconductors are also extremely important in the physical world: cars, factories, robots, and industrial systems. They quietly support almost everything around us.
So they are the silent, overpowered background character type.
That is surprisingly accurate. Now, we are entering one of the most important topics in modern AI hardware: HBM.
The ultra-speed memory monster from earlier.
Exactly. One of the biggest realizations of the AI era was this: a powerful GPU alone is not enough.
So, the protagonist still needs teammates.
Very much so. Think about what GPUs actually do. They perform enormous amounts of calculations extremely quickly. But calculations require data. And if the data cannot arrive fast enough, the GPU starts waiting.
So, the army of 10,000 workers is just standing there awkwardly, waiting for supplies.
Exactly. That is why memory bandwidth became critically important. AI is not just a computation race anymore. It is also a data delivery race.
So, modern AI is basically math, traffic control, logistics, and electricity, all combined into one giant chaos machine.
That is honestly pretty accurate. And this is where HBM comes in. HBM stands for high bandwidth memory. It is an ultra-fast memory technology placed physically very close to the GPU.
So, the supplies are stored right next to the workers.
Exactly. By reducing distance and increasing bandwidth, GPUs can receive data much faster. Modern AI accelerators are increasingly designed as GPU plus HBM together.
So now, memory companies suddenly became main characters too.
Exactly. That is why companies like SK Hynix, Samsung, and Micron became much more important during the AI boom.
The memory faction has entered the championship arc.
Now let us imagine what an actual AI server looks like internally.
Finally, the forbidden backstage tour.
Systems like ChatGPT run on enormous clusters of AI servers. And inside those servers are huge numbers of semiconductors working together.
Not just GPUs?
Far from it. First, you have the GPUs themselves. Those perform the AI calculations. Then you have HBM. That supplies massive amounts of data at extremely high speed. Then there are networking chips. Because modern AI systems require huge numbers of GPUs communicating with each other.
So, AI servers are less like computers and more like gigantic industrial logistics centers.
That is actually very close to reality. And then there is power management. AI servers consume enormous amounts of electricity, so analog semiconductors are needed to stabilize voltage and current.
So, even if you have amazing GPUs, without memory, networking, and power systems, everything collapses.
Exactly. That is why the AI era is not just about one company winning. It depends on an enormous semiconductor supply chain working together.
So modern AI is basically humanity assembling the world's most expensive teamwork project.
That is honestly a pretty accurate description. There is another really important point we should talk about here. Japan is still extremely important in the semiconductor industry.
But I always hear people saying, Japan lost the semiconductor race.
That idea is only partially true. It is true that Japan is no longer dominating the most visible logic chip companies like NVIDIA, Intel, and TSMC. But Japan became incredibly strong in other areas: materials, manufacturing equipment, and power semiconductors.
So Japan became the hidden endgame support character.
That is honestly a very good way to describe it. Modern semiconductors require huge numbers of specialized technologies: silicon wafers, chemicals, lithography systems, and inspection equipment. And Japanese companies are deeply involved in many of those areas.
So, behind every NVIDIA is amazing headline. There is secretly an entire group of Japanese companies going, yes, hello, we brought the materials.
That is surprisingly close to reality. Companies like Tokyo Electron, Shinetsu Chemical, Screen, and Adventest remain globally important.
This industry really loves the quietly overpowered engineer archetype.
It absolutely does. And recently, power semiconductors became increasingly important too.
Another new character has appeared?
Power semiconductors are specialized chips used for handling large amounts of electricity efficiently. They are critical for EVs, factories, robots, and AI data centers. As AI systems consume more electricity, power control becomes more important.
So, the AI era secretly turns into an electricity management simulator.
That is honestly one of the core realities behind modern AI. AI may look like intelligence from the outside, but underneath it relies on computation, memory, networking, and electricity, all working together.
So AI is not just a brain. It also needs blood vessels, lungs, muscles, and a giant electric bill.
That is actually an excellent summary. All right, let us summarize everything we covered today. First, logic semiconductors. These handle calculations and decision-making.
The brain department.
Exactly. Next, memory semiconductors. These store information and feed data into AI systems.
HBM became the elite supply delivery squad.
Pretty much. And finally, analog semiconductors. These manage electricity and power systems.
The support class that everyone ignores until the entire server explodes.
That is unfortunately not far from reality. And the most important point is this: modern AI requires all of them. GPUs alone are not enough. You also need memory, networking, power delivery, cooling, and manufacturing infrastructure. The AI era exists because an enormous global semiconductor ecosystem works together.
At the beginning, I thought, wow, GPUs are amazing. Now I am like, dear God, every single person in this factory is suffering together.
That is actually a very important realization. That is all for today. Next time, we will explore something even bigger: physical AI. How AI is starting to leave the digital world and enter reality itself.
So we are finally entering the robots become real story arc.
Honestly, we may already be there.
Thanks for watching today's video. See you next time.